Morning. Okay, so we will have the review today, and your exam will be this Thursday. Okay, so let's start with. So I will go over the mock exam, and if there's any question we can ask after the mock exam. Okay, so let me pull the mock exam up. Okay, so since this exam is mainly sets and functions, so you won't have like proof like induction in the first exam, but there will be questions that you need to explain your answer. All right, so the short answer question, like it will not be like a formal proof, but there might be parts like you need to explain how it works. Like for example, here, the first question, can everyone see the question? Okay. So here's asking, does there exist a bijective function between the set of real number and the set of integer? So what's the answer here? Okay, I see people say yes, there exists. Now, if there exists, what's your bijective function? Then you need to give an example of such function. So if you say yes, you need to give a function. Anyone? Okay, I see people say, does x over x squared work? Well, x over x squared will be simplified to 1 over x. Is that what you mean? You want to have y equals to 1 over x? Okay, let's see what happens. So this means you want to let f of x equals to 1 over x. Now, is this a function from the set of real number to the set of integer? Right, for example, when x is 0, 0 is a real number. What's 1 over 0? Undefined. So it's not, so on 0 does not have an output. So this is not a function from the set of real number to the set of integer. Do we see that? Now, what does it mean to have a bijective function? or what condition does it need to satisfy in order for a function to be bijective? Okay, I see people say injective and surjective, and what else? Like, what do we know here? We know the input set is a set of real number, and we know the output set is the set of integer. If our function is bijective function, do we know anything about the cardinality of the sets? They need to have the same cardinality, right? So if, okay, so we want to find a bijective function from the set of integer to the set of real number. Now, we know for every bijective function f from A to B, the cardinality of A need to equal to cardinality of B. Now, is the cardinality of the set of real number equal to, okay, so here we have, it's actually from the set of R to the set of Z. Now, is the cardinality of R and Z the same? They are not, right? How do we know they are not the same? Well, we know are the set of real number, it's uncountable. It's uncountable infinite set. Where Z, the set of integer is countably infinite set. So we know the cardinality of R does not equal to the cardinality of Z. Therefore, there is no bijective function from the set of real to the set of integer. Any questions here? So you need to explain that it does not exist because the cardinality of R does not equal to cardinality of Z. One is countable, one is not. Any questions here? Okay, if not, we will move on. Okay, next one. Now it's asked you to determine which of the following sets are finite, countable, infinite, and uncountable. So if you look at the first one, right, the set of rational number between 0 and 120. Well, is the set of rational number countable? We did that in class, right? How can we represent rational numbers? Or integer over another integer, right? So we know the set of rational number is already countable. Then the set of rational number between 0 and 120, it's a subset of the rational number. So if the set of rational number is countable, then you taking part of it, it will be countable. Is it finite? Is the rational number between 0 and 120 finite? Finite means you are able to list, okay, finite, then you will be able to tell me how many rational number between them. Then if I ask you how many rational number between 0 and 120, how many rational number are there? Right, so we know there are infinite many number in the there are infinite many rational number between 0 and 120. So this is an infinite set, but it's countable because the set of rational number is countable. So when you take part of it from 0 to 120, it's still countable. So the answer will be, this will be a countably infinite set. Okay, now what about the set of integer between 0 and 120? Right, it will be finite, right? So if we include 0 and 120, then there will be 121 number, right? So it's finite. We're able to tell exactly how many elements are there. Now next, what about the real number between 0 and 120? Okay, I see people say finite. Then how many real number between 0 and 120? Well, we check the real number, right? All the real number, that means it include the irrational, or you can have numbers with infinite many decimal places. And we actually in class we check the real number between an interval, right, from 0 to 1, and we show that that's not countable. Right, no matter how you list out all the elements, you will always be able to find a new element that not belongs to your list. So this will be uncountable. Okay, I see people asking why is the rational number between 0 and 120? Well, we know rational number can be written as 1 over, can be written as an integer over an integer, right? So you want to find all the rational number between 0 and 120. There are infinite number of rational number between any two interval, between any interval. Because if you just look at it, well, we know 1 over 1, it's 1, it's in between this range. Now, if you just take 1 over 2, it's also a rational number. It's in that range. And you can just do 1 over 3, 1 over 4, 1 over 5. Then So just looking at 1 over an integer, there are already infinite of them. And they are all between 0 and 1. So you know there will be infinite element, but there are like infinite rational number between 0 and 120. Does that make sense? Okay. Next, what about the set of negative rational number union with the set of negative integer? So you combine with the set of negative rational number and the set of negative integer. Well, is it finite? No, right? It's infinite. So if it's infinite, then we need to check is it countable, is it uncountable? No, is it countable? So ICP will say yes, right? It's countable, and it's countable because we have the set of negative rational number union with the set of negative integer, and we know rational is countable, integer is countable. And if we take countable union or countable, or if you combine two countable, it's still countable. Okay. Now here, the set of rational numbers between negative 120 and 0, and you will intersect with the real number between 0 and 120. Okay, CPO say uncountable. Now if it's uncountable, what's their intersection? What's the intersection of the set of real number between negative 120 and 0 and 0 and 120? What do they have in common? Okay, CPO say finite. Right, so the only intersection is 0. Right, because one is 0 and down to negative 120. The other is from 0 to the positive 120. So we are looking at the intersection of these two sets. So the only element that they have in common is the 0. So we know this set is finite. Any questions here? Okay, people asking why is C uncountable? Since we are looking at the real number, right? In class, we check the real number between 0 and 1, it's uncountable. So if you just scale 0 to 120 to 0 and 1, right? If you whatever we did in class with real number between 0 and 1, you multiply that function by 120, you will get this set. So since that set is uncountable, this will be uncountable. Or if you just look at it, the set of real number between 0 and 1, which is like a part of real number between 0 and 120, where the smaller part is already uncountable, then from 0 to 120 is also uncountable. No, the real number. Okay, so if you look at if you write it as fraction, that's the rational number. The set of real numbers, or if you have irrational, right? The real number include the irrational number, which means you might have numbers with infinite many decimal places and there's no pattern. Yes, but there's no pattern, so you won't be able to list all of them out, right? In class we did that. If you list out all the real number between 0 and 1, no matter how you list it, you can always generate a new number that's not in your list. Okay, I see people asking what's the difference between that and rational number. Rational number is a number you can write it as fraction. Not all the real number are able to write as fraction, right? For example, the pi, 3.1415 and so on, right? Pi is not a rational number, right? You can express it as a fraction. Okay. So are we good here? Okay, next. So here we have 4 different sets, and then the first question is asked for the what's the universal set? Well, we know the universal set is the set contain all the elements appear in the question. So you just take down all the elements. So you have A, B, C, D, E, F. Then you have W, X, Y, Z. E already have. We need to include K. X we already have. Z we already have. And then we need to have T and F we already have. So this will be your universal set. You just take all the elements, you union all the sets. Okay. And next you want to find B intersect C union D. So B intersect C, that means you are looking for whatever they have in common, right? B and C, what B and C have in common. Now B and C, they both have X and they both have Z. So you have X and Z in your set. And we also need to take the union of D. Right, so we have T and F. So this will be the set. And next, we have A minus B minus C. That means you take the element in A, and then you will get rid of all the element if it belongs to B and also belongs to D. So if you look at A have A, B, C, D, E, F. Now, if you look at it, we need to subtract the B. B have W, we don't have W, we don't have X, we don't have Y, we don't have Z. So there's nothing you need to get rid of, right? So this is the same as A minus B. Now we also need to minus D. So if we have T, we need to get rid of T, but we don't. And we also have F, so we will get rid of the F. So this will be A minus B minus D. In other words, we are looking for the element in A, but not in B and D. So anything that's in B and D cannot be in here. Good. Okay, next. Okay, I see people say, what if it was D minus A minus B? Then we be D first. Yes, so you're looking at the element in B, but that's not in A minus B. So what's A minus B? A minus B is the same as A since they don't have anything in common. Then you're pretty much just looking at the set D minus A. So every element in D, but not that's not in A. So you take T and F, get rid of the element that's in A. So that will just give you a set containing T. Okay, next. We want to find the power set of D. So the power set of D will be a set containing the empty set. All right, and then we can have the empty set containing T, containing F, and then containing T and F. So this will be the correct answer. Now I see people have the answer. You have the set containing T, the set containing F, the set containing T and F, and then you should have the empty set instead of the set containing the empty set. You don't have another empty set inside. Okay. Why do we put the empty set? Empty set is a subset of any set. Right? Remember, empty set and then the set itself is always a subset of your set. So you always have the empty set and then the set itself as an element in the power set, since that's the subset of it. Okay, and then we will look at the Cartesian product. Well, Cartesian product of C and D, C and D. That means it will be the set containing, now Cartesian product is ordered pair. So you will have first element in C and then the second element in D. So you can have that. You can have E and F. And then you can have K and T.
Excuse me, Professor.
Yes.
Does it have to be in that exact order?
You can put it in the element, you can put in any order, but the order pair, you need to have the first element from C, the second element from D.
Oh yeah, I know that, but does it have to be like ET, then EF, or
Oh
ET?
no, you just need to list out. You just need to list out all the elements.
Okay.
And here you can have X, P, and then you have X left, and then you have Z, T, and then finally you will have Z, F. Okay, so you should have a element there. Okay. Next is asking which set is disjoint with A. Disjoint means they don't share any common common element. Now, if you look at A have A, B, C, D, E, F. Now it does not have any common element with B, so A and B are disjoint. Now, if you look at A and C, they both share E, and then A and D, they both share F. So the set B. Okay, and next we want to find the cardinality of B cross D cross D, which means you just want to find the size, right? So you have B cross D, which means you have 4, right? The cardinality of B is 4, cardinality of D is 2, so I have 4 times 2 times 2. And that will give us 16. And the cardinality for A, cardinality for power
Wait, can you
set.
do the last one? Can you do G again? I'm sorry.
Okay, so this we want to find the cardinality, which means the size of B cross D cross D. And we know the cardinality of the Cartesian product will be just cardinality of each one, and you multiply it. So we know the cardinality of B is 4. Cardinality of D is 2. So we have 4 times 2 times 2. If you express the element out, then that means you have the order 3 tuple. So,
Okay.
so the element will look like WTT, WTF. So your first element is in B, the second element is in D, the third element is in D. Right, so here it's like how we have the order appear. Now you have 3 elements. Right, but
Okay,
since
okay.
there's a lot, so I did not ask you to express. I just asked you how many elements are there.
Okay.
And for the cardinality of power set of A, well, power set, we know the cardinality of power set is 2 to the cardinality of the set. So if you look at the cardinality of set A, it's 1, 2, 3, 4, 5, 6. So your answer will be 2 to the 6. And 2 to the 6 will be 64. Any questions here? WTT, WTT. Yes, but not in the not with the set notation, with the parenthesis, since this is the order tuple. Okay. So next question. Now here they ask you to give example of 2 countably infinite sets where A union B, first is finite, second is countably infinite, and then C is uncountable. Okay, in the previous question, how do we get 64? There are 6 elements in set A. And to find the cardinality of the power set is 2 to the cardinality of A. So 2 to the 6 is 64. We derived the formula in class. But every time you increase an element, you double the cardinality. Right, so since we have 6 elements here, then the size of the cardinality will be 2 to the 6. Good. Okay. So next, so it asks you to find 2 countably infinite set where A union B is finite, B countably infinite, and C uncountable. So if you look at for A, if you have 2 countably infinite set, by union then can you have finite set? The answer will be no. Right, so for A, the answer is impossible. since infinite, since union of any two infinite sets are infinite. Right, so it asks you to give an example of each three condition. So the first one is impossible. So we can find A union B where it's finite. Now for B, can we find example where A union B is countably infinite, where A and B are countably?
Yes, when like let's say A is all even numbers
Okay,
and
so let A to be the set of all even numbers,
B is the opposite, so it's odd.
and B will be the set of all odd numbers. Then A union B will be the set of all integers, which they are all countably infinite set. Now, what about set C? What about C? Can we find A and B where their union is uncountable set? No. So we know this is impossible. Since union of any two countable set is countable, so it cannot be uncountable. So any questions here? You can just use the word, just write union and intersection. You don't need to use a symbol. Or you can use and or. Intersection means and union means or. Okay, next one. Okay, so we know AI is equals to negative I and positive I. Okay, so here we have, it's asking what's A120. So if AI is negative I and positive I, then A120 will be negative 120 and 120. Then the union from I3 to I5, that means you have negative 3 and 3. And then you have -5, -4, and 4, -5, and 5. So you have -5, -4, -3, 3, 4, and 5. So you take union of them. Now for the intersection, that means you want to find what they have in common. Now if you look at A2 intersect with A3 and A4, what they have in common will be empty set. They don't have anything in common. Now union from A1 to the infinite set, it will be the set of all the integer except 0. So you can write that as the set of integer minus 0. Or you can just say the set of all integer except 0. Right? Since you have all the negative number from 1 to infinity, and you have all the positive integer from 1 to infinity, but you don't have 0. And I see people asking, it's not infinite. What do you mean by it's not infinity? Infinity is not a set. It's not a number. Infinity is just a concept expressing there's like a very large number. Okay, now for the intersection, if you look at it, none of the sets have common element.
Excuse me,
So-
Professor.
Yes.
For D, can't you just say that it's natural numbers and not 0?
But if you do the natural number, then you don't have the negative number.
I mean, don't we already not have negative numbers?
Now we do have negative number.
Okay, it comes with the set already. Okay. All right.
Right, so each set it will have the positive I and negative I. So if you union from A1 to infinity, then you will have -1, 1, -2, 2, -3, 3. And so you have all the negative integer and the positive integer.
Oh, okay, okay.
Okay.
Yeah.
Let's see here. Okay, so here it asks you to give a pair of A and B such that the cardinality of A intercept B is 3, and the cardinality of A minus B is 3. And the cardinality of B minus A is also 3. Now it asks you to find the example. Right, so this means now I see people say it's possible. So if it's possible, then you will give example, then just give example of A and B. Now let's see how do we do it. Well, first we know their intersection is 3. That means they will have 3 elements in common. Right, so we can do A. Okay, if we just use number, we can do 1, 2, 3. So let's say they both have 1, 2, 3 in common. Then that means their intersection will be 3. They all have 1, 2, 3. Now A minus B equals to 3. That means there exists 3 elements that A have, not in B. So we have 4, 6, 7. So B does not have 4, 5, and 6. Now B minus A is also 3. That means B exists 3 number does not belong to A. So we cannot have 4, 5, 6, since they can only have 3 number in common. Then we can do 7, 8, 9. So this one, right? Since A intersect B, x 1, 2, 3. Right, so there are only 3 elements. Now a minus b will give you 4, 5, and 6, only 3 elements. And b minus a give you 7, 8, 9, also only 3 elements. Okay, so it's possible. So here's an example. Next. Now here it asks Kagan, does there exist a non-empty cell of A and B where it will have the same cardinality from A cross A to the power cell of B, where there exists a bijective function. Now to find a bijective function, if we want to have a bijective function from A cross A to power set of B, then we know the cardinality of A cross A need to equal to cardinality of power set of B. Right. So let's say cardinality of A equals to X and cardinality of B equals to Y. Then we have cardinality of A plus A equals to X times X. Right, which means we have X squared. Now cardinality of B, it's Y, then the cardinality of power set of B will equal to 2 to the Y. And we want them equal to each other, right? And we want X squared equals to 2 to the Y. So what do we know about X and Y? Therefore, X need to be 2 and Y need to be 2, which A and B need to be a set with 2 elements. So if you do 1, 2, and let B to be 3, 4, that's fine. So you just let A and B to be any set with 2 elements. Any questions here? Okay, next. It's asking what's the cardinality of A. So if you count, we have an element 1, we have an element 2, we have an element 3, the set containing 3, 4, and the set containing 5, 6, 7. So there are 4 elements. The cardinality is 4. And next, we're asking, is empty set an element in set A? Do we have an element of empty set? No, so this is false. Now, is empty set a subset of A? Yes, right, empty set is a subset of any set. Now, it's one element of A. True. Is 3 an element in A? So it's false, right? Since our element are 1, 2, a set in another set. So 3 is not an element. What about the set containing 3? Is the set containing 3 an element in A? No, right? We don't have a set containing 3. We have the set containing 3 and 4, but not the set containing 3. So this is false. Now what about, is the set containing 3 a subset of A? It's false. Right, since we don't have 3 in our set, so it cannot be in the subset. Now, is the set containing 3, 4 an element in A? This is true. Now, is it the set containing 3, 4 a subset of A? Will be false. Now, what about, is the set containing 1, 2 a subset of A? Yes. Now, is there an element of A? False.
Excuse me, Professor. For H, can you explain why that's not a subset of A?
Which one?
H.
Okay, the 3, 4 here.
Mhm.
Okay, so
Yeah.
here we want to find, is this a subset? Subset means this is like a smaller set of A. Now, if this is a subset of A, that means 3 is an element in A. Is 3 an element in your set?
3 is an element in that set, yes.
Is
Oh,
3 an element in the set?
Can you say that one more time?
Is 3 an element in set A?
No.
No. So the answer is not. Right. So if 3 is not an element in set A, then it cannot be in the subset.
Okay.
You see that?
Yes.
One easier way to look at the subset is if you get rid of some element in your set, you will get the subset. Now, what element do you get rid of to get the set containing 3 and 4? Nothing, right? So if you look at it here, let's say you want to get rid of the okay, so let's say you want to get rid of the 1, and then the 2, and then this element. Now, what's your subset look like? You will have a set containing the element 3 and 4. So this will be the subset. We see that it will be the set containing the element where the element is a set containing 3 and 4. It's not the set containing 3 and 4. Like there's a difference between them. Here. Now do you see it?
Kind of.
Right, 3, 4, it's an element in your set A.
Mm-hmm.
But the set containing 3, 4 is not a subset, right? A subset means your A, that means 3 must be in your set. Okay, this means 3, the element 3 need to belong to A, and the element 4 also need to belong to A. But is 3 and 4 elements in A?
3 and 4 is not element A currently.
Right? So it's not in the subset.
Okay. So wrapping my head around it.
Good.
Almost. But it's fine. You can move on.
Okay, so this is I think the last question on the mic exam. Okay, I see people say, why is the cardinal the 4? Okay, so let's see what's your element in the set. So here it's an element. Here's the second element. Here's the third element. Here's the fourth element. So you only have 4 elements. So 1 is element, 2 is an element. The set containing 3, 4, like this set, the whole set is an element. And then the set of 5, 6, 7 is an element. So that's why when we look at the subset, 3 is not an element in A, so it cannot be in the subset. Four is not an element in A, so it cannot be in the subset. But the set containing 3, 4, this is an element in set A, right? We just circled here. So that's why if you go down, there's a difference between G and H. G is true, not H. Are we good here?
Okay, I get it. I get it. I understand H now.
Any other questions? Okay, if not, we will end the review section here. And I will see everyone Thursday. Well, okay, so so not really like a specifically the ceiling floor function or the logarithm function. I might give you a function where I ask you to give the input and output set. So to make the function 1-to-1, ohm-to, or like injective but not surjective, surjective but not injective. Or I can ask you, so either I will give you a function and ask you to give me like the input and output set, or I can give you the input and output set and ask you to give me an example of the function that satisfies the condition. Now the exam format will be similar to this exam. So you won't see like a lot of proved. Right, so mainly like short answer, fill in like there's like multiple part question. And if it's short answer, you can just briefly explain it. Okay, about the subset. A subset of B doesn't necessarily mean A.
Excuse me, Professor. Can I ask you a question just to see if I can understand this?
Yes.
So say we have a set of element A, element 3, and element set 5 of 4.
Okay, so what do you want to have?
And I want to have I wrote a question that says set 5 for subset of A is
5
false.
for subset of, wait, in a set of what?
This a set of 5 and 4,
Mhm.
element 4 and 3.
4 and 3 in a set?
We can work with that. So I just want to understand. So
So you want this to be your set?
that's my set, correct.
Okay.
And asking a question of is 4, 3 a subset of A? And I would write false.
Yeah, so it will not be, so the set, so if you look at 4, 3, or 3, 4, it doesn't matter since the set, the order does not matter. So this 4, 3 will not be a subset of A.
Mhm.
It will be an element of A. So you can say this is belong to A with this notation. You say this is an element in A, but it's not a subset in A.
Yeah, correct. Gotcha.
Because subset, by subset means 4 is an element in your set and 3 is an element in your set. So if you say the set containing, if you just have this will be a subset of A since 4 is an element in A,
Mhm.
but not 4, 3, right? Since 3 is not an element in A. But if you have things like, if you have the set containing the set 3, 4, this will work. This will be a subset of A. So you have the set containing a set of 3, 4, which is your element here. Right, this element is the same as this element.
Okay.
So do you see the difference between these 3?
I do.
Yeah. And I see people asking, A subset B, if A is a subset of B, it doesn't necessarily mean that A is less than B. Yes, because they could be the same set, right? Because A could be a subset of itself. So A is a subset of B does not imply A is less than B. But it cannot be, but certainly cannot be more element than B. Right. So so if A is a subset of B, it's possible that they are the same. But if you say A is a proper subset of B, then the cardinality will be less. Okay, so if A is 1, 2, 3, 4, 5, and B is 1, 2, and 7, B cannot be a subset. Yes, since B have an element that does not belong to A. Subset means every element in your subset will belong to your set. So you can think of subset as you are get rid of some element in your set and whoever the remaining set. So you can only get rid of the element, but you cannot add more element to it. A cannot be a subset of B because B does not have. No, it's not. B is not a subset because B containing 7. It's not because it does not have 3, 4, 5. It's okay you cross out some element. The reason B is not a subset since B contains an element that does not belong to A. The definition of subset means every element in your subset, it need to be in the original set. Are we good here? And can we explain the cardinality of powers? Okay, so the cardinality of the power set of infinite set will be uncountable, right? So you can do it. I think we kind of just talked through it in class. The proof will be similar to kind of similar to the real number proof. Is like if you list out all your sets, right? So then you can see, then we can always find a set that's not belongs to your list. So if you look at the Carnot power set of a set, it will always be greater, which means, so now we only learn about the countable set and then uncountable. So anything that's not countable, we call it uncountable. But even in the uncountable, there are some uncountable set it's greater than the uncountable set. So not all the uncountable set have the same cardinality. So if you keep taking the power set of an infinite set, you will get different layer of infinity. But that will be too much for this class. So we won't do that here. So just know that if you take power set of a set, the cardinality will always be greater, right? So if you take power set of a finite set, well, the cardinality is certainly greater since the cardinality will become 2 to the sets, right? So if you have a finite set with size 10, then the cardinality or power set of that set will be 2 to the 10, right? So your cardinality will be greater for the power set. Now, if you're taking the power set of a infinite set, just remember every time you take you're looking at the power set, the cardinality will be greater. They will be different level of infinity. To explain why we put. Okay, power set means the set containing all the subset of a set. That's what power set means. Like power set of a set S means a set containing all subset of S. An empty set is always a subset of any set. So that's why empty set is always in the power set. It's always, so the empty set it's an element in the power set, since empty set is always a subset of any given set. Are we good? Yes, I will upload the recording up probably in, I will try to upload it in next hour or two. Okay, and also go over the question we did go over in the lecture. Right, so not only the mock exam, and also all the question we did in class.
Excuse me, Professor.
Yes.
So will the chapter regarding logarithms, will that be included in this test? Because you didn't really go over that. Well, I didn't.
So if we didn't go over it in the lecture, then you don't need to worry about in the exam.
All right. Thank you.
Right. So mainly focus on things we go over in the lecture. So like if you look at all the question, the mock exam, all the question we go over in the class.
Okay. Thank you.
Okay, CPO say asking how many questions, roughly the same as the mock exam. If there might be 1 or 2 questions more if I put some multiple choice in it. So I will say roughly the same things. If you look at this mock exam, there is 8 questions, but there are I think 3 or 4 questions have multiple parts. So it depends on how many parts are each question. But it will be similar length. Okay, and I see people say, how do we type the notation, like this notation? If you say If you use the subset, A is a subset of something, or this is an element of something, it's fine. You can just use the word. Any other question? Okay, if not, we will end the class here and I will see everyone Thursday. Have a nice day.